Dear students, let's consider extreme cases of connection of RC branch to AC EMF source. We have got expressions for UC, a sum of UC forced and UC natural, and IC current through this branch, and it may be seen from this expression that they both depends on the level of initial phase of EMF, this PE level. Let's consider the so-called best case when no transient processes will happen at all. In this case, we may have when this expression under sinusoidal sign equal to 0, this expression, we will have sinus 0 equal to, it will be equal to 0, and A integration constant will be equal to 0 also, no transient processes at all. So we will have just UC will be equal just to forced component, and IC will be equal just to forced component also. And we will have such graphs of changing in time of voltage drop across inductance. It changes smoothly from 0 level to 0 sinusoidal level and further. And for current, as voltage drop across capacitance should not change abruptly, it should change smoothly like here. But for IC, for voltage drop, for current through capacitance, it may change abruptly to provide this smooth changing. So IC forced was equal to 0 before commutation, then it will change abruptly up to maximum level, and then it will change in accordance with a sinusoidal, here it is sinusoidal law. Okay, let's consider the worst case when we have here under this sign, sinusoidal sign, we will have 90 degrees level of initial phase, and therefore maximum level of sinusoidal function is +1 or -1. When it is possible, when this expression under this argument will be equal to 0, to minus or plus 90 degrees. It is this case, this argument equal to either plus 90 degree or minus 90 degree. Let's consider case when it's equal to minus 90 degree. Therefore, sum of this PE plus module phi will be equal to 0. These two items will be cancelled. Okay, so we will have under sign of sinus, we will have it will be as it is 0, so sinus of minus 90 degree equal to -1, and A equal to UC forced, because A equal to UC maximum forced, and as this coefficient equal to -1, it will be A will be equal to plus UC maximum forced, like here. You see, in this case we can write down UC as a sum of UC forced and UC maximum and UC natural in such a without any sinusoidal. Sinusoidal will be equal to -1. Yes, okay, to -1. So it will be just product of UC maximum forced and exponential function. This refers also to IC. It will be IC maximum forced sinus omega t for forced component and minus UC maximum over R in the degree minus T over RC. Let's construct graphs of such function. You see, it is this function is this function is UC forced. You see, this is UC forced. It is started from a -1 level at t equal to 0, okay, like here. And let's construct also natural component. Let's consider case of very slow changing in time, a very slow decrease of this exponential function when we have really large value of r, and therefore raise a large value of tau c equal to r multiplied by c. In such a case, diminishing of this uc natural will be really slow, and sum uc as sum of uc forced and uc natural will change in such a way. At t tends to infinity, this curve will approach this uc forced curve, but at the first at the moment of gaining second maximum of uc forced, when this maximum is summed up with uc natural, we will have pretty big level of sum of uc forced and uc natural, and it may, when r tends to infinity and tau c tends to infinity, we may have here a level twice as big as uc maximum forced. But it is considered as a rule that level of such magnification of uc is up to 1.8 of uc maximum forced. It is written here, and it is also maybe very unpleasant, so-called let's name it unpleasant case, when we have surge of current at the first moment after commutation. Such a case is possible in the contrary case, when we have rather a small level of r, and therefore 1 over omega c r will be really big, much bigger than 1, and therefore natural component can be much bigger than forced component. You see why it is here. We have uc, sum of uc forced and uc natural, and when r is really small, this coefficient may be really big in comparison with this coefficient before sinusoidal function. So just at the first moment of the commutation, we may have really big level of IC natural. It's equal to minus 1 minus IC maximum forced over omega CR, and it may be much bigger than IC maximum forced. You see, it is IC natural, this is IC forced, and this is, as a bold line is shown, their sum, and it will be rather quickly the same level of IC and IC forced, but at the first moment after commutation, level of as level of IC natural may be really big, sum of levels of IC forced and IC natural may be really big also, and it may be much bigger than IC maximum. Okay, let's stop for now, because we will not okay, let's do it in the next lecture. So you should understand, you should remember that when we connect IC source to RC RC branch, it is transient processes which complies which forced component complies with sinusoidal changing function, and natural component complies have the same form as for connected to DC source. It's integration constant multiplied by exponential function, and we have here several cases. First, when we have no transient processes at all at such condition, at such connection between psi, phi and phi, when their level equal to 90 degrees, and second, raise the bed, I mean for electrical schematics, bed case, when we have raise when we have sum of this function equal when it is equal to 1/2 of p, and therefore we have maximum natural component level, and when we have both so-called bad cases when R is really big. In such a case, we may have surge of really big level after commutation of UC, voltage drop across across capacitance, and when R is rather small in comparison with omega c, we will have surge of current because natural component current will be rather big. So bye bye for now. Please listen next lecture, and this lecture is over. Bye bye.